everyone. So I'm going to share my screen. Okay, last time actually we started chapter 4, okay, and in today's class we will cover MCQs from MCQs 50 onwards. Okay. Also, let me know about my audio quality. Also, I will make another class, okay, in which I will discuss about the electrical transmission, generation, and distribution. So we will discuss all these topics in next class, okay. थोड़ा सा वेट कर लेते हैं, बाकी स्टूडेंट्स ज्वाइनिंग कर ले क्लास को, फिर क्लास को प्रॉपर्ली स्टार्ट कर लेते हैं. सही है. Sorry, today we start from MCQ 61. Last time we did up to MCQ 60. उसमें अगर आप लोगों को कोई कंफ्यूजन हो रहे हैं तो प्लीज़ मुझे अपडेट कर लो कि कमेंट सेक्शन में, तो आई विल आंसर यू. Okay, so MCQ 61, that is two electrical appliances are connected in parallel to a constant voltage supply. Okay, the voltage is constant. Okay, if the current in one appliance is less than the second appliances by 1%, then power of the first appliances will be less by, so like you will need to find the answer in percentage. Okay, so in this case the voltage is constant. Okay, this is given to us, the voltage is constant, and the connection is in parallel. Okay, and we have two appliances, so let's suppose this is my appliance is 1. Okay, and the second appliance is this one. Okay, and both are connected in parallel, okay, to a constant voltage supply. So let's suppose this is my constant voltage supply. Okay, this is my appliances 1, this is my appliances 2. Okay, so and the difference, if the current in one appliance is less than the second appliances by 1%, so let's suppose the current in this appliance is the current okay, let's suppose the current in one appliance is okay, so let's suppose this the current in this appliance is 1%, and the current in this appliance is 2%. So the current in second appliances is less than the current in the current in first appliance is less than the current in second appliances by 1%. Okay, so we will need to find the power. Okay, so as we know that we have the formula. Okay, and that is my power, that is equal to V square divided by R. Okay, so why I am going to take V square divided by R? Because the voltage will remain constant in both appliances, so I am going to take this formula. Okay, and also like we have the formula, that is I is equal to V by R by Ohm law. Okay, so in this case in the first appliances the current is less, okay, by 1%. So it means that the resistance will have a high value by 1%. Okay, so if it is a high value by 1%, then it means that the power will have a less value by 1%. Okay, so in this case option 1 will be the correct answer. Yes, option 1 will be the correct answer. Okay, Okay, next MCQ is that is 62, and that is if R1 and R2 are respectively the filament resistance of 200-watt bulb and 100-watt bulb designed to operate at the same voltage, then okay, so you need to find the relation between R1 and R2. Okay, and the power is given to you, that is 200-watt bulb and 100-watt bulb. Okay, the voltage will remain constant. Okay, so as we know that P is equal to V square divided by R. Okay, so voltage is constant, so your P1 will be equal to V square divided by R1, and your P2 will be equal to V square divided by R2. Okay, so you will need to find the relation between R1 resistance R1 and R2. Power is given to us, okay, 200 watt and 100 watt. So you need to substitute the values. Okay, in this case I am going to substitute this value, that is 200 watt. Okay, that will be equal to V square divided by R1. Now for the second case, I will also substitute this power value, that is 100 watt. That will be equal to V square divided by R2. Okay, so over here you will substitute the value of V square. Okay, इसको substitute कर लो इस equation में. So you will get 100, that will be equal to 200 1 divided by R2. Okay, यहाँ पे हमारे पास आ जाएगा R1 divided by R2 will be equal to 1 divided by 2 हो जाएगा. Or you can say that your R2 will be equal to 2R1. Okay, so your R2 will be equal to 2R1, so option 4 will be the correct answer. Okay, yes, that will be the correct answer. Okay, next MCQ, that is 63. A generator produces 100 kilowatt of power at a, okay, generator is given to us, okay, and it produces 100 kilowatt of power having potential difference of 10 kilowatt. The power is transmitted through cable of total resistance 5 ohm. What is the power loss in the cable? Okay, so potential difference is given to us. Okay, and okay, this is the output power. Okay, potential difference is हमारे पास है 10 kilowatt. Sorry, 10 kilowatt. Okay, so the power transmitted to a cable of okay, resistance is given to us, that is 5. Okay, you need to find the power loss. Okay. Okay. Okay, so power loss, like as we know that P is equal to I square R. Okay, resistance is given to us, that is this one. You need to find the current. Okay, तो current आप किससे ऊपर से आप करंट फाइंड कर लेते, यहाँ से हमारे पास करंट आ जाएगा. That is P is equal to IV. Okay, ये फार्मूला अप्लाई करो, P is equal to IV. So your power is 100 kilowatt divided by 110 kilowatt. So kilowatt and kilowatt will cancel out. Okay, so your V will be equal to 10. Okay, आपका V जो है that will be equal to 10 volt. So sorry, your I will be equal to 10 watt. Sorry, 10 ampere हो जाएगा. क्या हो गया मुझे? I will be equal to 10 ampere. Okay, so over here your power I square will equal to 10, so 10 square will go to 100 times 5, so 500 watt. That will be the correct answer. Option B. Yes, option B will be the correct answer. Okay, next MCQ, that is 64. Okay, a constant voltage is applied across the end of the conductor. The heat produced is, okay, so a constant voltage is applied across the end of the conductor. We will, so the heat produced, so you need to find the heat. So as we know that heat formula is H is equal to I square RT. Okay, so voltage is constant. Okay, and okay, so as we know that you need to find the relation between heat and length. Okay, so we know that heat depend on resistance. Okay, and we also know that resistance depend on length and area. Okay, so that is equal to rho L divided by A हो जाएगा. So आपका ये क्या हो जाएगा? H will be equal to I square, instead of R you will put rho L divided by A and T हो जाएगा. Okay, तो it means that यहाँ पे हमारे पास ये आ रहे हैं, बट यहाँ पे हमारे पास फॉर्मूला भी है. ओके, यहाँ पे आपने ये मिस्टेक नहीं करना कि हीट इज नॉट प्रोपोर्शनल टू लेंथ, बिकॉज करंट also depend on voltage and resistance. So your this formula that will be equal to I is equal to V divided by R. So this will be V square divided by R square हो जाएगा. ओके, और ऊपर आपका ऊपर इसकी जगह फिलहाल हम ये R लिख लेते हैं. So what will happen? H will be equal to V square divided by R T हो जाएगा. ओके, अब R हमारे पास किसके इक्वल है? दैट इज इक्वल टू रो L डिवाइड बाय A T. ओके, सो यहाँ पे हमारे पास H इज इनवर्सली प्रोपोर्शन टू length. Okay, so in this case the heat produced is inversely proportional to length. Option B will be the correct answer. Okay, अच्छा, next MCQs, that is MCQ number 65, that is an electric kettle of 2000 watt contain 1 kg of water at 20 degrees C. Calculate the time required to heat water to its boiling point. The water equivalent of kettle is 0.5 kg, and this relation is given to us, that is 4.2 joule. That's equal to 1 kg. Okay, that is actually the relation is 4.18, but यहाँ पे इन्होंने approximation दिए. Okay, so in this case we need to find the time. Okay, so what will happen? Like I'm going to draw the diagram. Okay, let's suppose this is my beaker. Okay, and in this beaker we have water. Okay, and you will give heat. Okay, so let's suppose this is the water. Okay, so the weight of the water, that is 1 kg. Okay, and the weight of this beaker, that is 0.5 kg. Okay, so we have two formula. One is the heat produced by electric current. Okay, I square RT. We have this formula. Okay, and we have another formula, that is H is equal to MS del T. Okay, M is the mass of the liquid, S is the latent specific heat, and T is the temperature difference. Okay, so in this case the mass will be equal to the combination of these two. Okay, because here you have heat. Okay, इसके definition मैंने पहले आपको बताया भी था. So ये like you will need to give heat to this kettle as well as this water. Okay, so it means that heat is absorbed by this kettle as well as this water. So the total mass will be equal to over here you will take in gram. Okay, because the unit of this is equal to calorie. Okay, so this will be 1000 gram plus 0.5 kg. 0.5 kg is 500 gram. So this will be 15 100 gram. Okay, S is the one value in this case because this is the water and specific heat for water is equal to 1. So del T is like the room temperature 20 degrees C, okay, and you need to find the time required to heat water to its boiling point, okay, like how much time it will consume to its boiling point, okay. So you need to find that. So as we know that del T is equal to the temperature difference, so that will be 100 degrees C. The boiling point of water is 100 minus 20 degrees C, okay, that is the room temperature. So over here you will get 1500 multiplied by 80, that will be equal to, yeah, मैं mental multiplication भी कर सकती हूँ, okay, multiplied by 80, that's equal to 120 000, okay, this is calorie, this is in calorie, sorry, so you need to convert it into joule, so this will be equal to, you need to multiply it by 4.2, so it will give you 504 joule, okay, which is the unit of energy, SI unit of energy. So in this case, now you will substitute this value over here, so you will get 504, that's equal to I square R, that is the power, okay, so 2001 we put here, and that's equal to time, okay, that is we have to find that time, so this divided by 504 divided by 2000, that's equal to 252. But this will also be in okay, so this will be good 252. This will be in second, okay, so you need to convert into minute, which is equal to 4.2. So 4.2 minutes. So this option A will be the correct answer. Yes, that will be the correct answer. Okay, next MCQ, that is 66. That is an atomic power station of Tarapu has a generating capacity of 200 megawatt. The energy generated in a day by this station is, okay, so you need to find the energy generated by a day, okay. The power is given to us, that is P is equal to 200 megawatt, okay, and you need to find the energy source. We know that the energy is power is equal to energy per unit time, okay, that is equal to 200 megawatt, okay. So your energy will be equal to 200 multiplied by time will be equal to, in a day you need to find it in a day, so in a day we have in a day we have 24 hours, okay, and you need to convert it into seconds, so 1 hour we have 60 seconds, and in 1 minute, sorry, in 1 hour we have 60 minutes, in 1 minute we have 60 seconds, so your this value will be equal to 200 multiplied by 24 multiplied by 60 multiplied by 60. So from this you will get 17280. Okay, this is the energy you will get, okay. So you can write it like this, 1728 multiplied by 10 to the power 4, and this will also come over here. So in multiplication the power should be added, so from this you will get 1728 multiplied by 10 to the power of 10, okay, yeah. So option 4 will be the correct answer. Yes. MCQ number 67, that is An electric resistance coil of 60 ohm is immersed in 42 kg of water. What is the rise of temperature of water per minute if the steady current of 7 ampere is meant to flow through the coil? Okay. Resistance is given to us. Mass is also given to us. Okay. You need to find the rise in temperature. So, as you know, we have two formula, that is one is equal to the mc delta t. The second one is ms delta t. The second one is the I square RT. So in this case, resistance is given to us. Okay. Mass is given to us. Resistance is given to us. You need to find the rise in temperature. Sorry, this one. Per minute. So per minute means you have to find this one, that should be equal to 60 or h by t because current is given to us. Okay, so in this case, your h divided by t, that will be equal to I square system square is multiplied by r is 60. So h divided by t, that will be equal to that's equal to 2964. Okay. Two nine four zero. Sorry. 2940. Okay. So now what you will do, your this h will be equal to 2940 times t. You will need to substitute this value over here. So you will get 2940. T will be equal to m is the 1000 gram. Okay, s is the 1, and you need to find the delta t time. Okay, this will be in calorie, so you need to convert it into joule. So multiply by 4.2 भी आप निकालना. So इससे हमारे पास क्या जाएगा, टेम्परेचर पर मिनट. ओके, सो यहाँ पे हमारे पास आ जाएगा 2940 divided by that's equal to rise in temperature per minute per time हो जाएगा. ओके, सो यहाँ पे हमारे पास इससे क्या होता है 2940 divided by 4200. सो इससे हमारे पास आ रहे हैं 0.7 degree per, this is actually per second. Okay, so like you need to convert it into per minute. Okay, so per minute के लिए like in 1 minute we have 60 seconds. Kilogram, this is 42 kilograms, so this will be 42,000. Okay, multiply by 1. और मतलब यहाँ पे हमने ये मिस्टेक किया था, इसको 4.2 से ही मल्टीप्लाई करो, सो आपके पास जो में आ जाएगा. This will give you 42,000 multiplied by 4.2. So 176 यहाँ पे आएगा. 176,400. Okay, so 2940 divided by 176,400. So this will give you 0.0166. This will be the temperature per second. Okay, degree C per minute. Okay, we need to find the rise in temperature of the water per minute. So So यहाँ पे this will be per second. So you need to convert this into the minute. Okay. So in 1 minute we have 60 seconds. So you will multiply it by 60. So 0.99, which is equal to 1 degree C. That will be the this one. Okay. Okay, next MCQ, that is 68. An immersion heater is rated for 18 watt. It should heat a liter of water from 10 degrees C to 30 degrees C. That is near the. Okay. So in this case, power is given to us, that is 418 watts. Okay. It should heat a liter of water from, okay, temperature difference, that's equal to 30 minus 10, that's equal to 28 degrees. Okay, you need to find the time. Okay, as we know that H is equal to and also H is equal to MC delta T. So delta T is 20, S is 1, and mass is 1 liter of water. So actually 1 liter is equal to 1000 milliliter. This is also equal to 1000 centimeter cube. This is also equal to 1000 grams. Okay, so this will be 1000. So your H value will be equal to current value, that is power value is given to us. So instead of I square R, you will put power value and you need to find the time. Okay, so 20,000 divided by 480, that's equal to 47.84. Okay, so this is actually in calorie. So you need to convert this in joule as well. So you need to divide it by 4.2 as well. So 11.3. Sorry, this is in calorie. So you need to multiply it by 4.2. 1 calorie is equal to 4.2 joule. So this will be 20,000 multiplied by 4.2, 34,000 divided by 418. So 200 I can say. So time will go 200 seconds. Okay, so this will be the correct answer. Option B will be correct answer. Okay, second last answer, that is 69. Two bulbs of equal wattage, power is equal. Okay, constant, one having carbon filament and the other having tungsten film are connected in series to the main. Then okay, so in this case what we have carbon filament, okay, and we have tungsten film. Okay, so in this case power is constant, power will remain constant, like the watt is equal to each other. So both are connected in series. So in series we have current will remain constant. Okay, in both bulbs, constant current will flow. Okay, so then both bulbs glow equally, tungsten film will glow more. Okay, so in this case, as you know, the P is equal to I square R. So in this case, we will use power. Okay, and that is the proportion to resistance. So the resistance of the carbon is greater than the resistance of the tungsten. Okay, carbon is greater than the resistance of the tungsten. Okay, so that's why the power consumed in carbon uh, will have a high value. Okay, because in this case the glow will be more. Okay, like you can say your glow is directly proportional to resistance. If you have high resistance, so it means that it will glow more. Okay, like it will waste a lot of energy. So that's why the power consumed in this bulb will be more than this one. Okay, although the power rating is same. Okay, the power rating is same, but the power consumed in this bulb from the voltage source, that will be greater than the power consumed in this bulb. Okay, so that's why this will glow more than the tungsten film. Okay, so carbon film glow more. Okay, so option 4 will be the correct answer. Figure number 70, that is two wire AB with length in the ratio of 3:1, the diameter in the ratio of this with specific resistance. Specific resistance mean resistivity in the ratio of 1:20 are joined in parallel across a cell of EMF 2 volt. Okay, voltage is constant. Okay, and of negligible internal resistance. Okay, the ratio of rates of heat production. Okay, so you need to find the heat production. Okay, you have to find the HA divided by HB. Okay, over here the length that is given to you LA divided by LB, that is given to you 3 divided by 1. Okay, diameter is given to you DA divided by DB, that is 1 divided by 2. Specific resistance is given to you, that is resistivity of A divided by B, that's equal to 1 divided by 20. Okay, voltages both are connected in parallel, so voltage will remain constant. Okay, so in this case you can use this formula, that is I square R. I square, yeah, you can use okay, let's use this I square R T. Okay, acha, the voltage will remain constant, so you can use the another formula, that is H is A is equal to I V. Yeah, you can use this V square divided by R T. Okay, so both are will remain constant, so this will be V square T divided by R A, and your HB, that should be equal to V square T divided by RB. So what will happen? You can like write it like this, that should be equal to RB divided by RA. Okay, inverse relation. Okay, so now what will happen? Your HA divided by HB, that will be equal to rho LA LB AB into rho A LA divided by AA. So your HA divided by HB, that's equal to LA divided by LB, that is ये आपका नीचे LA divided by LB is 3 divided by 1, so ये आपका डिनोमिनेटर में आ जाएगा 3. Okay, DA divided by DB is actually equal to the R divided by 2, RA divided by 2, RA divided by 2, तो 2 कैंसिल हो जाएंगे, तो RA divided by RB you can use that's equal to 1 divided by 2. So pi RA square divided by pi RB square, so pi भी कैंसिल हो जाएगा, तो RA square divided by RB square हो जाएगा. तो RA divided by RB whole square you can write, so that's equal to 1 divided by 4. So instead of area is pi r square. Okay, so pi cancel हो जाएंगे और RA divided by RB, so RA divided by RB is 1 divided by 4 in this case. यहाँ पे हमारे पास अब आ जाता है resistivity, that is rho A divided by rho B, that is 1 divided by 20. Okay, तो ये आपका ऊपर 20 आ जाएगा. So इसको सॉल्व कर लो. 4 times 1 is 4, 4 times 5 is 20, so 5 divided by 3, that should be the final answer. Or 5 divided by 3 is 1.33. Okay, yeah, you can write in the ratio that should be 5:3. Like your 5 divided by 3 is equal to 5:3. We can write it like this. So option B will be the correct answer. Okay. Okay, so this is the end of this class. Okay, I will make another class after 15 minutes. Okay, 15 minutes के बाद मैंने दूसरा क्लास लेने, उसमें 71 MCQ से हमने आगे डिस्कस करना है, क्योंकि कल क्लास मिस हुआ था, तो कल का क्लास आज मैंने स्केड्यूल किया है, तो आई एम गोइंग टू मेक द डबल क्लास. सो सी यू सून. अल्लाह हाफिज़.